Oke, assalamualaikum warahmatullahi wabarakatuh. Di sini saya akan mereview video tentang reaksi kinetik pada laju reaksi di kimia dasar. Oke, di sini saya tidak sendiri. Sebelumnya perkenalan dulu, nama saya ADITYA GUMILANG PRATAMA dan nanti ada beberapa teman saya, di antaranya Bagas, ALIKHA, ALVINA, FAHRI, IHSAN, ZEIN, DAHLIA, ARMANDA, IFAAL, dan FERRY. Dalam video ini akan ada beberapa part untuk menjelaskan mereview videonya karena ini dalam bahasa Inggris, jadi harus direview kembali menggunakan bahasa Indonesia. Oke, langsung saja kita ke part video nomor 1 ya.
One of the most fundamental parts of usually in advanced chemistry courses to talk about kinetics or the rates at which chemical
Jadi di sini si Jamie itu dalam video presentasinya dia menjelaskan tentang salah satu bagian paling dasar dalam kimia dasar adalah tentang kinetika atau terjadinya laju reaksi pada kimia. Jadi laju reaksi kimia ini adalah sesuatu yang penting dalam mendasar bagi setiap siswa di kelas kimianya.
If you're noticing something isn't going fast enough, students usually know that you heat it up to make it go faster. So a nice elementary reaction that you can use to demonstrate what's happening with effects of reagent concentration and with temperature is to use the blue bottle reaction. What I have here are reactions that have already been prepared. I'll demonstrate them first and I'll talk more about the chemistry in a little bit. But right now we have the same contents. We have some methylene blue, some potassium hydroxide, some dextrose, and just water in each one of these bottles. The same concentration of all solutes and all reagents is the same for every bottle. The only thing I've done different here, I have 4 different temperatures. One of them's at room temperature. I do one with cool water. Usually I just take the cold tap water out of my sink. I have this one on an ice water bath, and then this one is a warm water bath.
Ini yang paling ujung ini dia suhunya panas, lalu ada suhunya suhu ruang dan suhu yang paling dingin.
37 Celsius.
Di antaranya suhu yang pada laboratorium dan BN1 itu 37 derajat, 25 derajat, 15 derajat, dan 2 derajat. Semuanya menggunakan suhu yang berbeda.
So we've got about 10 to 12 degrees difference between each one. You can try to get exactly 10 degrees Celsius difference. I've never been able to, so I don't bother.
Jadi masing-masing laboratorium itu memiliki perbedaan suhu sekitar 10 dan 12 sampai 12 Celsius.
These don't last very long. Now I do need a volunteer to help me out, so Peg is going to help me. In my classroom usually have a student come in and we just practice shaking, so that, we'll do it without the flashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Siswanya untuk membantu mengocok botol yang ada di dalam mengocok larutan yang ada di dalam laboratorium ya, selama 10 kali pengocokan, dan terlihat di sini terjadi perubahan warna yang signifikan. Jadi yang botol suhu yang paling panas yaitu 37 derajat, dia menjadi tidak berwarna atau bening. Lalu ketiga botol lainnya berubah warna menjadi biru.
This one's starting to fade, and then on down the line we get more and more fading over time. So what's happening here? In the hot flask or the warmer flask, those particles have lots more energy than they have in the cold flask. So we can get lots more energy going around inside the particles together. More particles, when they collide, have enough energy to make that chemical reaction happen. So because we have more particle motion, the reaction goes more quickly. We have more energy available to make that reaction happen. Here we don't have quite as much energy, and here these are taking a very long time. This can take up to 10 minutes sometimes. And I usually, if this one gets really cold down to like 2 degrees, sometimes it never even changes. There's so much that's
menjelaskan bahwa suhu yang paling dingin itu akan memperlambat laju reaksinya, sedangkan suhu yang paling panas akan mempercepat laju reaksi. Oke, mungkin segitu saja akan dilanjutkan oleh teman saya ALVINA dan ALIKHA.
Baik, kami akan melanjutkan presentasi selanjutnya. Presentasi selanjutnya tentang concentration of reagents atau reaksi dalam larutan kimia.
usually get a good picture for. Now, this one's temperature. We can do the same thing with
Sudah disediakan kalium hidroksida dan metil biru yang sebelumnya berubah warna. Perubahan warna pada metil biru itu termasuk dalam sebagian reaksi yang telah dilakukan.
So, we have different concentrations here.
Lalu digunakanlah konsentrasi yang berbeda. Untuk labu yang pertama ditambahkan 3 ekstra kalium hidroksida dan yang kedua ditambahkan 6 ekstra kalium hidroksida. Untuk melihat konsentrasi yang berbeda, maka dikocok terlebih dahulu sampai 10 kali.
Ready? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So same thing, we get a blue
Bisa
color.
dilihat hasilnya, pada labu yang tengah perubahan yang terjadi lebih cepat. Labu yang kanan setelahnya dan yang kiri masih memiliki warna biru pucat karena berisikan campuran larutan. Dan dapat disimpulkan bahwa konsentrasi kalium hidroksida paling banyak terdapat pada labu yang di tengah.
Potassium hydroxide, which one had a smaller amount of potassium hydroxide, and which one had no additional potassium hydroxide. So I can get a quick in-class assessment of what's going on. So we can see that
Jadi, bisa dikatakan seperti ini. Ketika ada banyak gas di atas saluran, kemudian dikocok dengan hitungan yang sudah ditentukan, maka yang terjadi ketika gas dan molekul X bertemu akan terlihat berwarna biru. Tetapi jika ada bahan kimia lain, kita sebut molekul Y. Jika dalam molekul Y akan bersaing, di mana molekul Y akan bersaing dengan gas untuk berikatan dengan molekul X. Dan yang terjadi setelahnya, gas dilepaskan kemudian akan kembali ke atas dan warna biru akan memudar karena molekul X dan molekul Y yang dicampur.
Di video ini kita akan menjelaskan tentang perubahan laju reaksi.
Now, to talk a little bit about what's happening here, you can also use this as a way to start talking about reaction mechanisms. Not all chemical reactions happen in one step, even though very often in a general chemistry course we just say reactants go to products, that's it. We don't say sometimes the reactant goes here and then here and then here and then becomes here and then it becomes product at the end. We're usually just worried about the net reaction. In kinetics, though, we're interested to see what steps, and if they ever go on to take organic chemistry, everything is about reaction mechanisms and what steps happen on the way to making products. So I'm going to go to the board and look a little bit at this reaction mechanism. One of the things that you have inside of this bottle, I found that my students in my advanced chemistry class, I just give them the blue bottle experiment at the beginning, and they hadn't seen it in my general chemistry class. I just put the bottle out there and I said make observations. Some of them will eventually shake it and suddenly it turns blue. They weren't expecting that to happen. And so that's a good inquiry experiment for them just to start asking questions and making observations the first day of class. What they don't realize, my students always think that this is the only matter inside of the bottle.
Dalam video tersebut menjelaskan tentang perubahan laju reaksi pada larutan metil biru dan larutan tersebut kita gambarkan larutan X, larutan Y, dan gas. Ketika labu Erlenmeyer dikocok terjadi perubahan pada larutan tersebut. Hal ini terjadi karena gas berikatan dengan larutan X, maka larutan akan berubah menjadi warna biru. Tapi hal yang menarik dalam larutan Y ini bersaing dengan molekul gas untuk berkaitan dengan larutan X, sehingga larutan Y berikatan dengan X dan molekul X pun menjauh kembali ke atas larutan. Dan ketika larutan X dan Y itu bersatu, maka warnanya akan kembali menjadi bening atau tidak berwarna.
I think this goes back to the if you can't see it, it's not their concept. But even after a full year of chemistry, many of my kids take about half the class period before they start thinking, maybe oxygen is doing something. So what happens is you have oxygen in the gas phase up here in the air. Well, oxygen can also dissolve in water. Otherwise, fish and aquatic species would have a very difficult time surviving. So it becomes from oxygen gas to aqueous oxygen. Well, once that oxygen becomes aqueous, it's free to move around here with whatever is inside of my flask. So it can react with the dextrose, it can react with the potassium hydroxide, it can react with the methylene blue. And it turns out that there are two forms of methylene blue. There's a colorless and a blue form. And I'm just going to say, to keep it simple right now, that it goes from methylene blue to the oxidized form of methylene blue. The oxidized form of methylene blue is blue. When it's not oxidized, it's colorless. Well, there's another thing. If something's becoming oxidized, something has to become reduced. So another reaction that happens, dextrose is just a form of glucose. When it goes into solution, we can treat it as the same as a glucose molecule. And what happens is the glucose with the strong basic conditions, this is about 2 molar potassium hydroxide or 1 molar potassium hydroxide, that can become the glucoside ion. Now, if you want to go into this into organic chemistry, we can explain that glucose is a molecule. They mostly know that from biology, but they also tend not to have seen it in this form. They just, do C6H6 or C6H12O6. And we can talk about, in basic conditions, alcohol groups can sometimes act like very weak acids. So under strong basic conditions, that hydrogen can migrate over here. You get a glucoside ion. And then this can go further and oxidize and make a carbonyl or a carbon to oxygen double bond. And at this point in time, I've lost every single student in my class.
Setelah pengocokan larutan, gas kembali ke atas, namun beberapa gas masih berikatan dengan larutan X yang menghasilkan warna biru. Jika gasnya kembali menguap ke atas, maka semua warna biru menghilang. Setelah larutan X berikatan dengan larutan Y, gas kembali naik ke atas.
Baik, di sini kami akan mereview tentang kimia organik.
Inside of the blue bottle when we agitate it on the molecular level. Now, we know how gases compare to liquids in terms of density, so anyone who's a gas molecule, please exercise your density. Gases are less dense, so they're going to float to the top. So inside of our bottle, we've got lots of gas on the top of our liquid here. Now, the first thing that happens is we shake the bottle up. Well, when we do that, the gas molecules and the X molecules can react together. So when gas and X meet, that's when we start to see the blue color. But the interesting thing about this reaction is there's another chemical in solution here. Y competes with the gas to bond to X. So Y can invade, steal X away. The gas goes back up to the top of the solution, and X and Y are now colorless in solution when they're partnered up.
Baik, saya akan menjelaskannya. Jadi di sini yang terjadi adalah di dalam botol memiliki oksigen fase gas di dalam botol, dan oksigen juga dapat terlarut dalam air. Oksigen gas menjadi oksigen yang terlarut. Jika tidak terlarut dalam air, spesies ikan lainnya memiliki waktu bertahan hidup yang sangat sulit. Sehingga dari gas oksigen menjadi berair, setelah itu bisa bebas bergerak di sekitar dalam botol atau labu. Jadi bisa bereaksi dengan dekstrosa dan bisa bereaksi dengan kalium hidroksida. Dan kalium hidroksida bisa bereaksi dengan metil biru. Metil biru memiliki 2 jenis, yaitu metil biru ada bentuk tidak berwarna dan metil biru. Jadi metil biru menjadi metil biru box jika teroksidasi warnanya berwarna biru. Jika tidak teroksidasi tidak berwarna, sehingga berubah dari metil menjadi bentuk teroksidasi metil biru. Jadi reaksi lainnya yang terjadi di dekstrosa hanyalah bentuk glukosa ketika menjadi larutan. Kita dapat memperlakukannya sama dengan molekul glukosa.
Dan yang terjadi adalah glukosa dengan kondisi dasar yang kuat ini adalah tentang 2 molar kalium hidroksida, 1 molar kalium hidroksida yang dapat menjadi ion dioksida.
The gas molecules and the X molecules can react together. So when gas and X meet, that's when we start to see the blue color. But the interesting thing about this reaction is there's another chemical in solution here. Y competes with the gas to bond to X. So Y can invade, steal X away. The gas goes back up to the top of the solution, and X and Y are now colorless in solution when they're partnered up. So we have a competition between reactions here. So we can simulate what's happening. So let's shake our whole bottle now. So we're going to shake everything up. Gases go down. Gas and X, you guys are bonding together. Gas and X, you guys are bonding together. Right here, yeah, right there. And then how about this gas and that X, you guys are going to bond together. All right, and everyone else sort of settle out. The gas will start rising back up to the top. All right. Well, now we have some blue in solution. Go ahead, stay blue here. Because it's not until Y invades and bonds with X for itself that the gas gets released to go back up to the top.
Glukos menjadi glukoside jika dalam kimia organik dapat dijelaskan bahwa glukosa adalah molekul yang sebagian besar mereka ketahui dari biologi. Dan juga dalam kondisi basa dapat dijelaskan gugus alkohol terkadang dapat bertindak seperti asam yang sangat lemah sehingga dalam kondisi basa kuat. Hidrogen dapat bermigrasi, berpindah tempat, di sini mendapatkan ion glukosida dan ini dapat melangkah atau berjalan lebih jauh dan mengoksidasi dan membuat ikatan rangkap karbonil atau karbon ke oksigen. Jadi, cara yang lebih baik untuk menjelaskan mekanisme menurut kami adalah mendapatkan konsep persilangan dengan cara yang sangat visual yang tidak melibatkan struktur apapun.
Saya di sini akan mereview tentang reaksi permulaan.
And then here's the playback menu so we can start the reaction. So you can see that my hand descends and shakes this up. I sped this up a little bit just so it takes a little bit more time. So this is twice the playback. But once that bottle turns blue, you can see that the dissolved oxygen increases in concentration. It then levels off, and as that blue color starts to disappear, there's less and less dissolved oxygen. So the dissolved oxygen is leaving the solution, going back up to the top part of the bottle. And then when we shake it again, we get another dark blue color. The dissolved oxygen concentration goes up. That blue color starts to fade just as the dissolved oxygen starts to decrease. So you can very clearly show to the students that it is the function of the oxygen that's causing this reaction to change color. The more oxygen that gets dissolved, it takes a little bit longer for it to start to filter out of solution, and they can see a really nice graphical representation that the dissolved oxygen is responsible for the color change that they're seeing. So it is the oxidation of the methylene blue that results in this reaction.
Lalu Anda goyangkan botol itu perlahan sedikit supaya bisa membutuhkan lebih banyak waktu agar pemutaran 2 kali. Setelah botol itu berubah menjadi biru, bisa dilihat oksigen terlarut meningkat dalam konsentrasi. Kemudian mendatar, dan ketika sudah warna biru itu menghilang, oksigen yang terlarut semakin dikit sehingga oksigen terlarut meninggalkan larutan, naik kembali ke bagian atas botol, dan kemudian ketika kita menggoyangkan lagi, kita mendapatkan warna biru tua. Lainnya, konsentrasi oksigen terlarut naik warna biru, mulai memudar tepat saat oksigen terlarut mulai berkurang, sehingga Anda bisa ditunjukkan dengan sangat jelas kepada siswa bahwa fungsi oksigenlah yang menyebabkan reaksi ini berubah warna. Semakin banyak oksigen yang larut, butuh waktu sedikit lebih lama longer untuk mulai menyaring dari larutan, dan mereka dapat melihat representasi grafis yang sangat bagus bahwa oksigen terlarut bertanggung jawab atas perubahan warna yang mereka lihat. Jadi oksidasi biru metilen yang menghasilkan reaksi ini, ada beberapa hal yang perlu Anda ingat jika Anda akan melakukan reaksi ini. Yang satu ini tidak dapat diatur pada malam sebelumnya, karena konstanta ketika reaksi diatur bersebelahan dalam waktu setengah jam akan mulai berubah kuning.
Kami di sini akan menjelaskan video tentang reaksi kinetik yang akan dijelaskan oleh Saudara Ihsan. Saudara Ihsan, dipersilakan.
Jadi di sini saya akan menyimpulkan video reaksi kinetik.
Things that you need to keep in mind if you're going to do this reaction. This one cannot be set up the night before because when the reactions are set next to each other, within a half an hour, they'll start to turn yellow. So what I do is I mix up the potassium hydroxide solution separately and the dextrose solution separately, and I just mix them together right before class and pour them into the flasks. You get about a half an hour of playtime before it starts to turn yellow. Even if it's yellow, you can still shake it and it will turn blue, but the longer it sits, the worse it becomes. I did learn this the hard way because I set this up the night before in my first year that I ever did this demonstration, and came back the next day and every bottle was blue, and I freaked out and had to start all over again, and I only had 5 minutes of my time between classes to set that up. So I would certainly recommend mixing up the potassium hydroxide solution and the dextrose solution separately, then mix them together at the last minute when you need them. You can use different indicators for this too. Reazarin will work and give you sort of a pink color rather than a blue color. So one time I even had half of the bottles that I gave my students be blue and half of the bottles be pink. You do need to make sure that they are sealed very tightly.
Oke, baik. Jadi yang dilakukan dalam video ini adalah mencampur larutan kalium hidroksida secara terpisah dan larutan metil biru secara terpisah juga. Terjadi perubahan pada lampu Erlenmeyer. Warna pada larutan berubah-ubah dari yang tadinya tidak berwarna menjadi berwarna. Adapun beberapa faktor yang mempengaruhi laju reaksi yaitu luas permukaan, konsentrasi, suhu, dan katalis. Yang dilakukan dalam video percobaan adanya faktor luas permukaan dan suhu. Suhu yang ada dalam lampu Erlenmeyer antara lain 30 derajat Celcius, 25 derajat Celcius, 15 derajat Celcius, dan 2 derajat Celcius. Semakin panas suhu maka akan semakin mempercepat laju reaksinya. Oke, segitu saja yang bisa saya simpulkan.
Sekian dari kami, kelompok 1 TI22B tentang reaksi kinetik. Kurang lebihnya mohon maaf. Assalamualaikum warahmatullahi wabarakatuh.